Welcome to the Optimum CAD solution. I am Pankaj Ratnabarki. Once again, we'll start our free online course that is Plastic Product Design and Advanced CATIA. In this video, we are going to see what is the concept of a doghouse, how it is used, and design of a doghouse feature. In a plastic injection molding parts, a doghouse is a specific structural engineering feature designed to provide a mounting point like screw bars, clip towers, locator on the B side, that is the B surface of our plastic part, without creating any visual defects on a surface, that is a styling surface. This use as a primary function to manage the wall thickness and height of the our feature from particular mounting point. Doghouse prevents sink mark on our part. It provides a structural support to the plastic parts, easy part mounting or locating. Also provide flexibility where our part has a mounting from the particular distance. It means it has a tall enough to clear the tool or to meet the mounting requirement and maintain the wall thickness. This feature is used widely in the dashboard design, car A pillar, B pillars, C pillars, then bumper design, door trims, and other plastic part. To learn detailed designing in the CATIA, connect with our YouTube channel. Thank you for watching. So without wasting the time, we will open the CATIA. So we'll start designing of a doghouse. For some engineering feature, we'll consider here a screw bars. So as usual, we'll take a origin, we'll take an axis system, select the sketch, select the desired plane, adjust the horizontal and vertical coordinates. So let us start with the basic sketch. So for the doghouse, we'll start with the basic rectangular. Give the desired dimensions. So here we'll give the 25 by 20 mm. Okay. So now next, pad command, but before that we'll insert a body. Give the particular name, whatever the name required. Okay, then we will go to the pad command. Pad, give the desired height. Here we will consider 20 or 30 mm. Now next, we have to clear our doghouse from tooling direction. So there are the two type of a tooling direction. First one is for particular feature, that is the doghouse, and another one is a common. Common, it means whatever the part you are designing and on which you are locating this doghouse or you are designing such features, then the tooling direction of that particular part also important. Okay, so here we'll just consider a basic tooling direction, but it might be different whenever we are designing or a part to part. Like for dashboard, we have a different tooling direction because of the feature and locator has a similar or a different kind of a orientation. So part should be clear from all direction. That's why follow the drafting. This, as I told, this is only a reference. So for practice purpose, you will consider the same tooling directions from which we are going to be draft our part. So here you can see our drafting is completed. So next is to give the radiuses. So you can see our if we see from the top, our part is get cleared. So now here we'll apply the radius of a 3 mm. Okay, top side radius. Okay, so here this platform is ready for designing the screw bars. So as we already discussed, for making a uniform wall thickness, because the if we apply the draft for particular part or a particular feature which is like the distance is almost 30 40 away from our basic surface, then it either required higher side thickness, or it might be loose, or whenever we are applying the draft, the 1.5 thickness get decreased whenever we are applying the draft at the top, or a topmost portion. So to overcome this issue, the doghouse concept is introduced. So let us take the new plane which is away from the basic plane. Let us start with the sketch. This is the screw boss. We are applying M5, M6, whatever the standard screw boss as per the mounting locations, or the part requirement. So this is the basic screw boss. As usual, the top Z direction is a tooling. So considering that, we'll apply the draft for this screw boss. Select the pulling direction. Okay, here's the basic boss is get completed. Now we'll apply hole command, and by using hole we'll apply the metric pitch. Before that we'll do chamfer 0.5 So normally we are not doing the whole operation in boolean operations, but here we'll just using this operation for understanding purpose. So threaded metric pitch M6, give the depth whatever you required, and also v shape at the bottom, so flat v bottom. Okay, thick depth we have to give at 1080 so now we will get a desired screw and its hole. So normally for the plastic, either we are embossing the screw boss in that metal screw boss, or undersize of a hole we need to design, because self tapping bolts or a nut or a screws we are using for the assembly. So now let's moving ahead for the strengthening of the screw boss. So we'll add the ribs. So once again select the sketch and follow the rib pattern. Whatever the pattern we require we can design, just this is for the reference. So our sketch is almost get completed. Now we will exit the sketching workbench and we'll use the pad command once again to emerge our ribs into our screw boss. So here give the whatever the pad height we required. After then, yes, definitely this part has to be cleared our tooling direction. So apply the draft on all the faces. Firstly, we'll clear from the top view. So let us see on the top, yes, material is get removed. Okay for the tooling. Let us give draft from the outside also. So for this we'll apply some higher side draft for giving some aesthetic look also. Not aesthetic but material minimum material maximum strength that we need to think. Let us chamfer out the corners. Select the edges and give the chamfer whatever we required. So give the dimensions requirement. So whatever shape we required we will achieve by chamfering. The material get removed. Here you can see. Now we'll apply the radiuses. So firstly smoothen out the edges. So by mistakenly we have selected the face. Instead of that, please remove the face, select the edge only. Yes, sometimes we did such kind of a mistake, so just concentrate on what exactly you are selecting. So here we'll just add some bottom side thickness to merge our top to our screw boss. Yes, so let us give name final body, final dog house. So follow this now we are just doing the boolean operations. First of all, we'll add all the positive sides or a positive bodies into the final doghouse. After then, before that, we'll just give the radiuses, and after then we have to remove inner bodies of the doghouse to maintain the wall thickness. So before that, we'll just finish out this radius operation. Either we can do at initial level also, or we'll follow this operation afterwards of the boolean completion. So as this part is not much more critical, we'll just finish out it at earliest. Yes. Okay, here now only the internal body is missing. Internal body removal is missing. So let us search out the body, copy, paste as a result with link. Give the negative side thickness whatever the required, 1.8, 1.5, 2 mm. So here we'll apply minus 1.8. So let us remove this body from our main body. So for easy purpose, we'll apply different colors. Green is indicating during the boolean operation. That's why please avoid to use the green color. So remove from basic body here. Here's our doghouse for the screw boss is completed almost. So let's how it looks on the wall. So for that just we'll draw one wall. So you can see the dog house is get completed, which is located on this wall. We'll hide all the planes for easy visual purpose. Yes. So now finally we'll go ahead for the draft analysis. So in the draft analysis, select the draft direction. Yes, select the part. Here you can see our part is completely passing out the tooling direction. So now we'll see from the top side. Yes, definitely in this case we required splitter also, otherwise a single direction also this part can be completed. Slider lifter is used in much more critical object, but this is a very simple object. It has a two drive directions or one direction also it can be passed. Thank you for watching the video. Please connect with us, subscribe our YouTube channel and hit the bell icon.